in this example, I'm going to go over a project. In this project, we're comparing Persian lime weights. Okay, so if we go to our project, here are the components that we need to complete for our project. So, starting with the first part here, okay, the next page is going to contain our claim, the null, and the alternative hypothesis. We have grocery store Persian lime weights versus USDA standard for Persian lime weight. Because the USDA has a tendency to underestimate produce weight, my hypothesis would be the following. So my claim is the mean weight of a Persian limes sold in grocery stores is greater than the mean weight of Persian limes as listed in the USDA Food Data Central Database. So therefore, I'm going to put in my alternate null hypothesis where we have the mean, which is equal to 67.0 grams, and the alternative is going to be the mean, which is greater than 67.0 grams. Now, if I wanted to come in here and put this information, I would come in here and select Insert, and I'd select Equation. And then I can type my equation in here. Now, if I wanted to type my equation, what I can do is the following. So in my equation, I would come in here, and then I would type in H, okay? And I'm just going to go ahead and put this in a different location. So let me go ahead and put this in a different location so you can see what I'm talking about here. So I'm going to come in here. And again, I'm going to go into Insert. I'm going to select Equation. And then what I would do is I would type in the following. If you go up here, you have your options. So you see here where it says script. Okay, I'm going to select this one because it has a subscript. So I would put H and then put in the value of 0 there. Okay, and then I would right click and then put in a semicolon. And then I'm going to put in this symbol. So the symbol is going to be located somewhere in here. So this symbol is going to be located here, and you can see my symbol is mu. And then I'm going to put in the space, hit equals, and then put in 67.0 grams. Okay, and then if I wanted to, on the next line, I would do the same thing. I'm going to come back in here, select Insert, put an equation, and then what I'm going to do is, again, I'm going to select this part here and put in H, and now put in the 1 for the alternative, and then put in my semicolon and use the right click key on my keyboard. And then again, I'm going to come back up here. Now, if I'm not seeing this information back on the top, you just want to come back up here and say Insert. Okay, just select Equation, and then it'll bring up the options. And then we're going to come down here and again look for the mu. And then this time we're going to put in the greater than symbol, and then we're going to put 67.0 grams. Okay, and then therefore that's how we generate the null and the alternative hypothesis. Okay, so coming back to here, you're going to see that we've already now created this scenario. Okay, so next what we want to do is we're going to go to the next page. It says data collection and the table of data. Okay, now the USDA lists the average mean weight for a Persian lime as 67.0 grams. So what you would do is, in order to test your hypothesis, you have 30 Persian limes that were randomly selected and purchased from a local grocery store, and each lime was individually weighed, and the weights are recorded here on the right. The values listed on the right are weights recorded for the sample of 30 Persian limes because we want more than 30. The sample mean and sample standard deviation are listed below. In order to do that, what I would do is I would come into StatCrunch, okay? And in StatCrunch, I would put in all the weights of my information that goes from 1 to 30. Okay, so there's my weights. Now what I want to do is I want to determine, this is the table, so I can copy this table and then put it in here if I'd like. So I can go ahead and then I can go ahead and copy this table, okay, and then put in that information over here. Now the next thing I want to do is I want to calculate the mean and the standard deviation. So I'd come in here, again I put in my title as Persian lime weights. I'm going to come in here and go to Stats, go to Summary Stats, select Columns, select Persian Lime Weights, and get the mean and the standard deviation, and select Compute. And you can see that my mean is 73.90, and my standard deviation rounded to 2 decimal places is 1.12. So again, I can come in here and I can use the insert and put in my equations to put in that information. So going back to my data here, it says here to make sure you put a table of data, and there's your table of data. Okay. Next, we want to verify conditions with the histogram of data, normal quantile plot, and a box plot. Okay, so what we're going to do is we're going to come back to StatCrunch. Okay, and so because we are checking the mean, okay, we are going to be using a t-test statistic because it's a student t-distribution, because we are comparing the mean. So therefore, I'm going to come in here to stat, and then I'm going to go down to where it says t-stats, and since I'm dealing with one sample, I already have the data in there, so I'm going to select with data. I'm going to select Persian Lime Weights, and then down here, I'm going to put in the information for my null, and we know that's 67.0. And then down here, the alternative was greater than. And then I want to show the critical value, and then as I come down here, I want to make sure that I highlight, hit the control button for the p-value plot, the histogram, the box plot, and the QQ plot. And then I'm going to select Compute. So I'm going to leave this data up here, and if I go to this next slide here, this is my distribution. So this is my bell curve. And then here is my histogram. If you right-click and select Copy Image, then you can bring it into this page here. So if you select Paste, then you can paste it into here. Okay, now it's already in here, and you're going to say the shape of the distribution for the lime weight and the histogram is normal. Okay, and then going back to our data, okay, we're going to select to the right, and now there is our box plot. So you can see here, if we select right-click and select Copy Image, then we can bring that in here by selecting that, and notice that there aren't any outliers. Okay, and then next we're going to come back here, and then if we go next, we can see that our QQ plot with the correlation statistic, so we right-click, copy the image, and then we can right-click in here and then bring it in. Okay, now remember the quantile correlation in the QQ plot is given here as 0.963, and it's greater than the critical value. Our critical value is by using the value of our sample size. Our sample size n is 30, so we get the critical value on our table, which is 0.960. And therefore, this represents our histogram of data, the normal quantile plot, and our box plot. Now if we come back here, here's our histogram of data, our normal quantile plot. Now our box plot just verifies there's no outliers, so it's a good idea to put that in here as well. Okay, next, we go to the next page. Okay, the null hypothesis test. We're saying that the data gathered from the random sample of 30 limes produced a normal distribution in the histogram, and the constructed normal probability plot had a correlation coefficient higher than the critical value for the sample size, and the box plot contained no outliers. Therefore, these results suggest the data come from a normal population. The following rules were set for this test. The alternative hypothesis contains the greater than symbol, so therefore a right-tailed test is appropriate. Assuming that the null is true and the p-value of the null is calculated within n-1 degrees of freedom with the following formula. This is a test statistic. The formula is given by the following. T is equal to the sample mean minus the population mean over the sample standard deviation of the square root of n. Now we can go ahead, you can copy this if you wanted to and bring it into your PowerPoint presentation, or you can create it using the insert equation. And then because the consequences of this test are not severe, this hypothesis test is tested at a significance level of alpha, which is equal to 0.05 level of significance. So therefore, this has given us the idea and given us a description of what's happening with your project. Next, the test stat equation and value. Now, a right-tailed test, hypothesis test at the alpha equals 0.05 level of significance produced the following results. We have a critical value for alpha is equal to 0.05 with 29 degrees of freedom, which is equal to 1.70. So we would get that on our table. And then we put in our formula, knowing that our sample mean from our data is 73.90. Our sample standard deviation is 1.12. The population mean is 67.0, and n is equal to 30. And then we plug it into our equation. So there is our equation, and then we show the result. So therefore, there's the test stat equation and the value. Next, we have our necessary descriptive statistics with p-value and the drawing of the distribution with tails and the critical value and test statistic. In order to get this information, we're going to come back to StatCrunch. So we're going to go here, we're going to select to the right, and then what you can do is you can just highlight all of this, right-click, okay, and then copy, and then you would come in here and then you would copy this information. So you can either copy it in this form, or in that form. Okay, keeping the text only is going to give you this result. So you can right-click and copy that in here. And then below that, you want to make sure that you copy the drawing of the distribution and the tail. So coming in here, going to the right-click, you can see here, we're going to right-click this information, copy the image, and then what we're going to do is we're going to paste it in here like I did. And so therefore, you're going to paste this information. Notice that it represents the t-stat. Now, where is the critical value? The critical value should be located here at 1.69, which is 1.70, and therefore there is the p-value. So therefore, there is the information for the descriptive statistics, the p-value, and the drawing of the distribution. Okay, next, now we need to talk about the conclusion, the line weight hypothesis test conclusion. We want to compare the p-value versus the significance level of alpha. Well, the p-value is less than 0.001, which is less than the significance level of 0.05, so therefore we reject the null. The p-value provides strong evidence against the null, therefore the null hypothesis is rejected, and the alternative hypothesis is accepted. So then we would say that there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean weight of Persian limes is greater than 67.0 grams. Okay, so therefore conclude that the mean weight of the Persian limes at the grocery store, okay, is greater than the 67.0 grams. And then we put in our sources. So now we go back here. Okay, now have we put in the table of data? Yes, we have. Have we put in a histogram? Yes. A normal quantile plot? Yes. Necessary descriptive statistics? Yes. We have our claim and our null alternative hypothesis. We have our drawing of the distribution with tails and critical value and test statistic. We have our test statistic equation and value. We have our p-value. We have our conclusion for the null hypothesis and the claim. And then the other parts that we grade are following the project directions and then the neatness and visual quality of the project. And so therefore, that concludes an example of the project.